Hello, this is Lindsay Boggs, and this is a video to show the Project 1 Sprite Mover for GPE 104. In this video, I'd like to show you the requirements of the project and how I've completed those, as well as the extra content that I've added in. So, in this first segment, I'm going to pop in and out of the game a couple of times just to show the different features that there are. I want to focus on the directional inputs. So there's two things that I had to do for this. First of all, we're going to be scripting in C#, which we'll go through at the end. We'll go through all of the scripts and the variables and why it's all where it is. Displaying a 2D sprite, making sure that it can move in the direction that the arrows are pressed. And then when we use the shift key, we're going to use a get button down. It was get key down, but I edited it. So that this only happens one time, or that only fires the first time, or the first frame that the button is down. And that will move the sprite 1 meter in whatever direction that it is that we're choosing. Let's showcase these requirements really quick. Just jump into the game. Down is down, up is up, left is left, and right is right. If I hold the shift key, I can, let me turn this volume down really quick, just because that's a little excessive. Right then, if I hold the shift key, make sure I'm in here, yeah, we're good, okay, and I press any of the directional buttons, it will move me to the right, left, up, or down by one unity unit. And if I select the player and show you that, you'll be able to see it update in the transform. So I'm going to go ahead and press shift and press my left key, and you'll see it updating here in the X position, as well as to the right when I press the right key. Up, you'll see it move along, and then also with down. And so each time I have to release the key and press it again, as the requirement stated, to get this to happen. I can't just hold the left key. Nothing would, I mean, it continues to play the animation. We'll go into why that happens. But it's not going to continue to move my character at all. So, let's go ahead and jump out of that. And then the second part of requirements here. If they press the spacebar, the sprite will be moved to the center of the world. Pressing the P key will, the component for moving the ship, or the character in this case, would disable, as well as re-enable when we press the P key again. So essentially it's pausing and re-enabling the game, if you really want to think about it. So we'll get into that, and then the Q key will completely disable the game object, and we'll break the game. We'll have to exit and re-enter in order to look at the last thing, which is using the escape key to close the project cleanly. And that we will show in the build. Make sure that this is, yeah, okay, just prep that. If you see me check this, I'm just checking my microphone, making sure this is still working. We don't want any technical difficulties. So this is the segment that we're going to look at: spacebar, P key, Q key, and escape key. So if we jump in here, we have the spacebar will recenter us to 0, 0, 0, or the center of the world. So we can walk wherever we'd like, hit spacebar, and here we are. We can walk all the way down here. Spacebar, as you can see, it maintains the last animation, which is an idle, and will just plop me right back to where I was at that 0, 0, 0 location in the world. Next is the P key, which will disable the ship, quote-unquote, or my player. So I hit P, and it actually pauses my game, which is one of the extras that I added, but any input that I'm putting in right now, it's not registering any of that until I hit the P key again to re-enable him, and everything is as it should be. All of my shift movements, everything's there. The next key is Q, and that will completely set him to inactive, which will remove him from the world, as well as our movement script and input, all of our input script, will be removed, so we won't be able to get him back, and we'll have to close and re-enter the game. So here's Q. Oops, wrong button. Q. Alright, the music stopped as well because the music was attached to him. But as you can see, there he was. We'll have to open the build. Oh, checking, testing. Yep, okay. Just making sure. We will open this build and open up my executable folder here. Go ahead and hit play. And here we are. When I press the escape key, it will close the app completely. And there you have it. So, next on the list, testing. Okay. To do is content that I've added along. So, we have in here testing. Test. Okay. Extra content, music and audio. This is going to be our background music. And then the P key has a slew of pause menu items that it also brings into play. And then the animations, the camera, and then I've added collision to the world. So, first, music and audio is attached to the player in this audio component. Let's go ahead and close all this stuff up so we can be a little more focused. This is the background music. So we have Goldenrod music, and I grabbed that from a YouTube video, so of course it's property of Nintendo. And that plays in this scene, and it starts on awake, and then it loops around. And the script has it. It's not in the script. Sorry, it's just in that one audio component. So we'll go ahead and hit play. And as you can tell, we have background music. One thing related to the music is that on pause, it will pause where it is in the song, and then when it resumes where it was. So if I go ahead and pause it, sorry, I'll stop talking for a second and let you get a feel for where the music's at, and then I'll pause it again. So, that helped with the whole experience of the game. At first, I was using mute and unmute, but it just felt weird. It didn't feel right, because it would resume at places where we didn't leave off, and it felt spacey. So I switched it to pause, and I'll show you where that is in the code in just a bit. Let's see here, music, and now we'll talk about the pause menu itself. So the pause menu, is going to bring up text and overlay, and it's going to play a little jingle when we pause the game. And then the designer is able to affect the volume of that jingle from the script, rather than going back down into the audio component and all of that. So, text, overlay, jingle, and volume. Here's our canvas, which holds our pause game display items. This is just an empty child game object, because if I were to add other things onto the screen, I would want those on a separate, organized differently, away from this stuff. So we have an image, which is just a transparent block, really, and we also have a text. So if I go ahead and render this and pop over to game view, the pause image is just this black transparent thing here. So just to show you that that's separate, I could change it to whatever color I wanted, and we'd be golden. And then we also have this text right here, and as you can see, it is completely separate, and I can edit it if I wanted to. So I could lie to them and tell them to press the A key, and they'd never get it unpaused. No, that would be bad. Anyway, that's the elements that make up the pause menu. And then from there, we also have to play a jingle when we press the pause key. So I've added that to my controller script. May or may not have been the best place for it, but that's where I placed it. So when we pause the game, we're going to play this jingle. This is an audio source, which is a component down here. It's the second audio source. So we have this pause sound effect, and that's linked up in here. And then the actual audio clip is in this audio source. So this audio source on the player links to this clip. The volume is editable from right here, but rather than find the audio source, of which there are two, locate that, and then mess with the volume, what I've done is I've added a public float so that the designer can pick a number between 0 and 1 and adjust the volume. So I'll let you listen to it again, how the pause jingle and everything works here. So if I hit pause, and then it resumes, hear that little jingle when it enters, that little doo-doo-doo-doo. Alright, that is the jingle. But if I were to, say, set the volume to 0, you can see that it updates in the script, and that it's conveniently placed there for the designer to use. You can tell that it doesn't trigger that sound at all. Let's check on my microphone. Yes, okay, we're still audible. It's important. Okay, so those are the components of the pause setup. And then we talked about that. Animations. Okay. This is going to be a lengthy section. So, the animations were not a requirement. Oh, and I can go ahead and disable my canvas. We do that in code anyway, in case I were to leave that open or whatever, so that does not start the game paused. But we'll get to that when we talk about code. Right then, animations. So, we will go into our walk animations, click on the player, animation bar. Alright, let's just move him up. Oops, I forgot the audio thing is attached to him. Oh well. We have a down animation. Actually. Aha. Okay. We have a down animation. We have a idle down. Oops, that's not idle down. That's idle down. Just one frame. We have an idle side, which is just him sitting there. We have a idle up. We have a walking upwards animation. And we have a walk cycle. Notice we don't have a right or a left, because this just gets flipped. There's a flip X function in the renderer, and that's what we use to go right and left. And we'll talk about that in code. Another fun thing about the animations is that you can obviously affect their speed. So if I wanted him to, like he had somewhere to be, just step him up to 12, and he'll get all his steps in for the day really quickly. But we're going to keep him at 6. And all of these animations by themselves are not connected. In order to connect it, we had to implement an animator. So, if we pop over here, this is how all of the animations transition from one to the other. And they're based on conditions that I've defined here. Just checking. Okay. Right. So, in order to transition, you have to have conditionals. And I've created my own. I have an is moving, and then this underscore nm is for my own references to know that these are variables within the animator, because I have similarly named variables within my script. So this is just me keeping things organized. If you notice, if I wanted to add a conditional, I have the options of a float, an integer, a boolean, or a trigger. What I don't have is a string, and that's what I wanted to use, was a string for this player-facing animation. I wanted to use a string, either, check if the string is equal to up, if it's equal to side, or if it's equal to down. But since I don't have a string, I had to improvise, and my improvisation was an integer. So, we use the numbers 1, 2, and 3 for up, side, and down. So, up is represented by the number 1, side, which is walking, whether it's left or right, is represented by the number 2, and down is represented by the number 3. So if we look into all of these transitions, if the player is going down, so it's within this third of this little graph, we're going to get the number 3. So anything coming towards down is only going to occur if the player is facing direction 3, or the down direction. So there's all of that, as you can see. And then anything that is going to the side is going to be direction 2, or equals 2. and then anything going towards up is going to be direction 1 for up. So we have upside down, 1, 2, 3. The other conditional is moving. So if the player is moving, it will go towards either player up, player walk, or player down. If the player is not moving, or if this is false, then it will direct itself towards one of the idle animations, either idle down, idle side, or idle up. And the way that it decides that is based on if the player is moving or not and what direction they're facing. So seems simple, took a long time to coordinate all of this, and in hindsight, using this any state probably would have been a good way to go, but this works, so I kept it. And as you can see my thought process, that's where everything is. And of course, we enter the game on idle down, because it just looks more proper that way. So now we get to explain this all in code, which is fine because we won't talk about those codes as much. Let's go ahead and open up the script. Check and make sure. Testing, testing, yes. Okay. Player controller. Alright, so to describe this script as a whole, there's two main parts to it. There's what the script does while the game is paused, and what the script does while the game is not paused. So we're going to look at these two main areas. We have void start, we have void fixed update. I changed it to fixed update because of the camera behavior when the player sprite was interacting with collisions in the world. It was shaking and it was just pretty disturbing. So I changed it to fixed update and it fixed the problem and everything else worked perfectly. So that's why I kept it like that. So these are the two functions that we call from this script. And then the fixed update, which is the bulk of this script, is divided into when the game is paused or not paused. So I would like to show you when the game is paused, because that's the smallest piece first. So if the game is paused, there's really nothing that we can do. What we're looking for is input to unpause the game. We don't want to do anything else while the game is paused. So if the game is paused and the player is trying to unpause the game, which is the only thing they can do while the game is paused, we're looking for the input from the P key, and we only want to fire it the one time that it is first pressed down. So that's why we have get key down rather than get key, because that would have fired on every frame. So get key down for P, and we're going to update our Boolean variable. So this is paused, we're going to set to false. Our pause canvas, which I showed you, was that transparency in the text and everything on the canvas. We're going to deactivate that because it was previously set active, because right now the game is paused and we've just unpaused it. So we're going to resume the game. We're going to get rid of that pause canvas and we're going to unpause the music, or resume the music, and then we have this debug log resumed game. So we'll talk about these variables and how they came to be at the very end, kind of going from the bottom up here. So the fixed update. The first thing we're going to do is update any variables that need to be updated. So within the animator, first of all, this my animator here I've set right up here. It's an animator object, if you will, element, whatever you want to call it, called my animator. And from here we can set the variables here. We can set this is moving anim. We can set the player facing anim. So we're going to set them, and on every frame, because it could change at any point. We're going to constantly be setting this is moving anim to the is moving from within this script, and we're going to be setting the integer value player facing anim from the player facing integer within this script. Testing. Okay. Right then. So keeping those two things in mind, that we're setting the is moving and the player facing constantly, we enter this state of when the game is not paused. Okay. So if the game is not paused, or if paused is paused equals false. The first thing we're going to do is enter this if and else if block here, and that is going to cover all of our movement pieces. So the special controls, so that's the things that are held with shift, and then also just the normal controls. And then that block will conclude before we get into our special things, but we'll talk about that in a moment. The reason I chose to do an if and else if thing, just right down the line, is because I only want one of these things to occur at a time. I don't want anything occurring simultaneously, and that was my way of safe blocking it, so that only one of these things could happen. So the first thing I'm going to do is check to see if the player is being funny and if they have opposite controls pressed at the same time. This comment says W and S because I originally used get key, but then I wanted to be more flexible, so I changed it to button. So ignore that comment, but it remains. This is what this piece of code does. So if the up button is being pressed and the down button is being pressed at the same time for however many frames it fires, I would like it to do nothing. I don't have any movement command in here whatsoever, and we're going to set is moving to false, because this will actually bring, if the player was moving previously and then they suddenly press both like these opposite buttons, it will bring the player to a halt, or the sprite rather to a halt. We update this is moving to false, which, as I mentioned, feeds back into our animator to tell it to go to an idle animation. So that is the first thing that we check, and then we're going to check if they're doing it in the opposite direction, so left and right, and if they are, then don't call any more movement commands, since those are called in every frame, and then once again set is moving to false. And now, once they're done being opposites, we're going to enter our shift controls, which was a requirement of the project. So when we hold shift and then press a key, we're going to move 1 meter in either direction, any direction, but only for each time the player presses the button. So they have to release it and press it again in order for us to move another meter in whatever desired direction they choose. So, we have here, if the left shift is being held or is down, then on the first time that the up button is pressed, we will fire this code. That's this get button down right here, not get button. So we will only do this once until they release it and then press it down again. So for the first time the button is pressed down, this code will trigger, and we're going to add the vector 3 to our current transform and add that back, or set it equal to itself again. I'm sorry, I can explain that better. We're going to take our transform and set it equal to itself plus vector 3, thereby moving it up by just 1, since vector 3 is like 0, 1, 0, if I'm not mistaken. The next thing we're going to do is we're going to take our player facing, which is an integer, and set it to 1, because I'd mentioned before we have no string variables in the animator. So player facing is going to equal 1, which in this case is up. So we're telling it we'd like to travel up, we want our player to face up, and we'd like to be moving. So is moving is going to be true, which gets fed back into the animator and lets us actually like move, like animating wise, rather than having an idle position. It's exactly the same for left, right, and down, other than we're adding vector 3 left, vector 3 down, and vector 3 right. So it's just directional. It's like 1, 0, 0, negative 1, 0, 0, and 0, negative 1, 0. And then we'll also be updating our facing status. So 2 is to the side. So on both the left and the right movement, player facing gets set to 2. And in all cases, we're moving at this stage. So, did I look at down? Here's down. Okay, yes. Player facing is set to 3 on down, because 3 is the direction, is the integer for down. Now, normal controls without the shift key. I do check to make sure that the shift key is not pressed. That's just me being semi-redundant. but also just to make sure that nothing happens that is not intended. So, while the up button is pressed, but not the shift key, we are going to simply move up, but times my speed, which is a public float that the designer can set. So if we go ahead and take a look at the player here, this is a script component, and we have this here, my speed. So we have it very small, 0.07. So at 0.07 times that vector in order to move up. So it would be, rather than 0, 1, 0, it would be 0, comma 0.07, so 7% of this, and then of course 0 for Z. And we'd travel upwards, and we want the player to be facing up, which is 1, and then is moving to true. Same thing for left, right, and down, except just as before, we're updating this vector 3 to be dot left, dot down, and dot right. And then once again, player facing gets set to 2 for the side, 3 for down, 2 for the side again, and 1 for up. Special controls. These are, that was the second part, how I split it into two. Starting with the space bar, going from the P key, the Q key, and the escape key. These are no longer in the if-else block. Is this still functioning? I hope so. Okay. They're their own thing, so these can happen simultaneously with anything else above. So if the player were to press the space bar, it's going to reset their transform to vector 3.0, which is just 0, 0, 0, center of the world. When they do that, we'd like to stop moving, or trigger an idle animation, just appear to be smoother. And then if they were to pause the, oh, and that is get key down, by the way, space. So it's only going to happen the first time that the spacebar is pressed, and if they hold the spacebar, it would have the same reaction. They would have to release the spacebar and then press it again in order to fire this code. So then we can pause the game, which once again is a single fire thing. This get key down, so it's the first time it's pressed. For P, to pause the game, we update our boolean, which is pause is set equal to true. We take this pause canvas and we set it to active, which I had showed you before, and then is moving is false because we don't want to be moving while pausing the game. So that'll tell our player to pick one of our idle animations from our animator. And then we are going to take the music, or the audio component that we have on the player, and audio source component rather, and we're going to pause it. So we call it the pause function, and then we're going to play the pause jingle, which is that little thing that plays when you pause it, and then we get this debug. So if we wanted to quit the game while, this is all happens while the game is playing, we would hit the escape key, and that would allow us to quit the application, and it would just give us the debug quit game. That only happens the first time the key is pressed, like all of the other things here. And then deactivating our player component. So if we press the Q key, we would disable or set active to false on our player game object, and that would kill this script as well. So there's no way to get it back. And then we give this debug log deactivated player object. We'd have to exit the game and re-enter the game in order to test anything else or to even play. And then I added this in as well. So if the player is not pressing any of the directional buttons, if the up button is not being pressed, if the down button is not being pressed, the left button is not being pressed, the right button, etc., we're just going to set is moving to false to trigger an idle animation, because there's no moving animation, moving input being given, therefore the player is idle, and we need to set the idle animation. That was just a debug thing that I was testing with, don't worry about that. Lastly, we talked about this already, if the game is paused. The other thing about pausing the game in terms of input, when we pause the game, there's no more input being taken because we've now is pause is equal to true. So this condition is no longer met. This is paused equals false because it's not. It's equal to true. It's equals to true because we just set it equals to true. So we enter this right here, and there's no movement input being accepted within this block. So that's what gives the effect of disabling the player, or disabling input rather. And we already addressed this section of code. So now talk about some variables. We have private variables and public variables, of course, and some special things that I set off to the side because I didn't want them to be messed around with. We have the transform, the sprite renderer. Our private boolean is paused, which, as you've seen, plays out a lot in this script. And we also have this audio source called mymusic, and that is the first audio source that's on the player, and that contains the background music for Goldenrod City. I do have another audio source that's public, and I will discuss why that is. So, the first audio source, which we call mymusic, or the background music rather, we're going to set that within the very start of the game and void start. So we're going to get the component audio source, okay? Because this is just the name of the component. However, I have two components. I did this before I added the pause jingle. So when I added the pause jingle, I didn't want to call this again because I figured I'd get the same thing. So I wanted to be clean and clear and make everything the way it's supposed to be. So I made a public audio source, which is the second audio source component on the player object for pause jingle. And from there, I drug in my my audio clip, so it makes more sense to just look at this player. I have this pause jingle comes from a audio source component on the player. So everything is self-contained right here. It's the second audio source. So I drug this in and dropped it right like that. Okay, so when this is linked up to the second audio source, we get the audio clip pause effects. Okay, so that's how that's kind of all chained in there. If we have a look at this, I also have a public float to control the volume. I believe I mentioned it before. As you can probably tell, I did record this video already, and then it had no audio. So I'm just checking my microphone, but I'm also trying to remember what I've mentioned to you and what I haven't mentioned. So I apologize if I've already mentioned this, but the pause jingle volume is a public variable so that the designer could enter whatever float between 0 and 1 they wanted and affect the volume of the pause jingle so that everything's just boom, boom, boom right together. For pause canvas, pause jingle, pause volume, it's all right there. So here is a half volume for the pause jingle, so it's pretty quiet. I could set it back to 1 where it belongs, or I could set it to 0 and if I set it to 0 it wouldn't play at all. But it's just more convenient to be able to edit it right there from one of the upper components that's less involved. Here it is not playing because the volume is to 0, as opposed to going back into the second audio source and messing with the volume right there. So, other things variable-wise. Float is my speed. I already addressed that, how we can adjust the speed of the character. We could, for example, set it to, let's just say 0.5, and you can zip around here. But keep it at a 0.07. Make sure everything's set there. And then we have this self game object is just so that I could drag the player object from the hierarchy into the inspector and make sure that we could disable ourself on cue. The animator was just to make sure that was all hooked up correctly, dragging the animator into the animator slot to control our conditionals on there. Where is it? It's in update right here. That's the only place where my animator is used, is within this update thing to set its boolean and integer values. The other public objects were the pause canvas, just dragging that in, the pause jingle, dragging that in, and then the float for the volume. And so it was either with the intent of making it more convenient for the designer, or it was me wanting to be thorough and making sure that I had the correct object selected. So that is my entire controller script. There's a bit more than controlling, but that's where we're at with that. So the next thing I would like to talk about is the camera and the world collision, and then we will wrap up the video. So, I followed a tutorial on the camera to get it to follow the player. I could have just attached it to the player, but I had some issues with collisions. And at first, when I added collision to the world, and the player would collide with something, so if I just enable the buildings really quick, to give you an idea, on here is a square box collider. It's a little hard to see. Where's your box collider? There it is. I have to click on the component. It's just this fine green line here, but that is collision. So if I were to, for example, run into the corner of that, my player object could actually spin like this and then continue upwards at a really random angle, as if he was still walking to the right, but he was doing the moonwalk, and it was not desirable for in-game purposes. So, I had to do something about that, because when he would spin, so too would the camera. And you couldn't get it back. So that's why I followed a tutorial to get some scripting controls for the camera, and all it does really is sets the camera position in relation to the player without twisting it around or anything like that. So there's really not a whole lot to talk about there. Yes, I'll save my script. And then I fixed the collision with the player so that he wouldn't himself rotate anymore, like I'd shown you, by finding a constraint on the rigid body to freeze the Z position. And that kept him linear, up, down, left, and right, as opposed to spinning when he interacted with a collision. So, I added collision to the world, as you briefly saw with the buildings. Buildings represented in white, and all these are purely collision boxes with some sprites there for my own benefit. And then of course I disabled the renderer, which you can tell is right there. So there's one right here, for example. So they appear invisible in game, but I can find them should I need to. Fences are blue, and the signposts are green. It also helps me to see where all the collision is in my world, so that the player doesn't go walking off into space. You'll notice I didn't include collision on any of the houses that the player could not access anyway. I like to do things in a very minimalistic way, and I feel that adding extra things that don't get used or aren't needed can cause problems. So I try not to add things that don't need to be added. But as you can see, he's perfectly confined and blocked off and can't escape anywhere. This background is all one piece. So I would not be able to move these houses around if I wanted to. They're set there in stone, if you will. If I were to actually create a Pokemon clone, as I wanted to note here, I would take each of these houses and make it its own object, I would cut it out of the thing or find the actual sprite for it, so that I could place them and organize them as I wanted to, as opposed to being limited to just this one sprite, with its backgrounds and everything else. The next thing to do would be to create prefabs, which I found to be very useful in Unity. A prefab can be created by clicking on an object from the hierarchy and dragging it into the project tab, and it saves the, I don't even know what you want to call it, just the data for that object in all of its instances. So here's an instance of an item, and here is another instance of an item. So if I wanted to change something about this, say I'm tag this as untagged, okay, I could go ahead and hit apply. First of all, let me click over here and show you that this one is tagged as potion at this point, and this one is tagged as untagged. They're prefabs, but they're their own unique instances. But when I apply the changes to the prefab, it will update all the other instances, so I don't have to go through. And if I had like 50 of them in here, I wouldn't have to select them all and change them individually. I could hit apply, and then this one is also deemed untagged. And likewise, I could change it back by tagging it as potion and hitting apply, and now they're both tagged as potion. The reason I added those tags was because I wanted to implement a pickup system where those could actually be destroyed and picked up. But it brought me just a little too far down a road that was a little bendier than I thought it was going to be. So I left them in there to show examples of prefabs and to explain the thought process and other improvements I'd like to make as soon as I learn how. I even have the sound effect put in here, so I can share that with you just for fun. For when it gets picked up, which is the same one by the game. No, I don't want to do that. I just want to hit the play button. So yes, that is the sound that would play when that object is destroyed and picked up. And that's also why those tags exist. Because I imagined doing something with those. And I do believe that is everything. So I've covered this content. We've coded in C#, we've displayed the sprite, it adheres to input from the player, they can modify it with the shift key and only move 1 meter for each key press. We use the spacebar to reset to the center of the world, the P key will pause and unpause. The Q key will disable the entire game object, and the escape key will exit the thing cleanly, and I've shown you all of this content. So that is it for Project 1 Sprite Mover for GPE 104. Thank you very much for watching.